Okay, welcome back. In this video, we're going to talk about core skill C7, which is two conditions and two unknowns. You can see the learning goal there. I can notice when two conditions create a system, write two equations, and solve for two unknowns. So a hook there is just what makes a system. So I have a couple prompts, and for each one, we're going to look at what's in common, what are the unknowns, and what are the conditions. We're not going to actually solve these prompts yet. So prompt A is two numbers add to 18. The larger is 4 more than the smaller. And then prompt B is a line f of x equals mx plus b passes through the points 2, 5, and 5, 14. So as usual, I'm going to give you a minute, pause the video, and you're asking yourself, what do these have in common? What are the unknowns? And what are the conditions? And as always, we'll kind of run through these in the I do's in a minute. So pause, take a shot. Okay. So first one here. So this is that prompt A. So two numbers add to 18. The larger number is 4 more than the smaller number. Find the numbers. So this kind of question should be familiar from Math 10. We've seen this kind of like this hidden system. So I have it broken down, and we're kind of on the lookout for a system. But what we're really looking for here is a situation where we kind of have two facts that deal with the same things, because we know if we have one equation, one missing variable, we can solve it with algebra. If we have two missing variables with two equations, we can solve the system, right? So that's kind of what we're looking for. So as I look at this question, I'm saying, well, okay, two numbers add to 18. So there's one thing about the numbers. The larger is 4 more than the smaller. That's a second thing about the numbers. So there's two missing numbers, two variables, and I know two things about them. So I can at least set up a system and take a shot at it. Now, when I'm doing this question, once I've kind of diagnosed the system, the first thing I recommend doing is define the variables. So I always look at what is the question asking me to do. So here the question is saying find the numbers. So AKA, what are the numbers? So I'm just going to define the variables. I can be creative here. I don't have to be. I don't usually like being creative, so I'm going to simply say let x and y be the numbers. And actually specifically, because one's defined as larger, I'm going to let x be the larger number. So I'm going to say let x be the larger number, and then let y be the smaller number. Okay. So once I have those, I'm going to create my equations. So I said earlier, I'm looking for two pieces of information to tell me about two different things. Each piece of information is going to be an equation. So two numbers add to 18. So that tells me that my number x and my number y are going to add up to 18. So there's equation 1. And again, I got that from this piece of information. And then equation 2 is going to be the larger is 4 more than the smaller. Now, there's a lot of ways to set this one up. The way I see it is I say the larger number minus a smaller number leaves me with 4. That's how I like to see it. You can see algebraically, you can manipulate that. So you could say like the smaller number plus 4 is the larger number, or the larger number minus 4 is the smaller number. Those are all equivalent. It doesn't matter. Now, the way I have it set up, I'm going to solve the system. And the goal of this video is not to solve the system, so this is a pretty easy solve. The goal is just to kind of recognize that system structure. So for me, this is a really easy system. Elimination or substitution is good. This is kind of prototypical elimination though, right? So what I'm going to do is to solve it, I'm just going to kind of put equations 1 and 2 on top of each other. So equation 1 again was x plus y is 18. Equation 2 is x minus y is 4. And then I'm just going to add those two equations up. And that's going to leave me with 2x, 0y equals 22. So that tells me that x is 11. So once I have x is 11, I'm going to go to either equation 1 or 2. Here I'll go to equation 1. X plus y is 18. But I already know, I think I know anyway what x is. It's 11. So 11 plus y is 18. That's a weird 8. So y is going to be 7. So therefore, now make sure I made up these variables. So I'm going to go back to the question. So therefore, the numbers are 11 and 7. And that's it. Done. So that's it. So again, we could see I knew I was missing two things, but I had kind of clues about those two things. So I tried to set up the two equations. I got down to two equations, two variables, and then that just becomes an algebraic skill. Just solve. Yeah. So kind of looking, so you can see, yeah. So that system was hidden in the word, and the question doesn't kind of come out with a neon sign like solve the system. It was just any one of these kind of setups where you have two pieces of information but two missing things or think consistent or even more. Like, so we generally say 2x2s, but there's no reason why it has to be two. It could be three. I have three pieces of information about three missing things. I can solve it. Okay. So I'm going to put one up for you. So your question is about notebooks and pens. I'm going to tell you that two notebooks and three pens together cost $16. Four notebooks and one pen cost $22. I want to know how much does each notebook and each pen cost. So before you pause, you're just thinking, what are the unknowns? What equations could you make? Again, kind of tell yourself, like, why is this even a system? That's another great kind of thing to know. Like, why even treat it like a system? Let's pause the video, try this, and I'll pop up the solution. Okay. So here's your solution. So here I got a little creative with my variables. I used n and p. And note to my definition, n is the cost of a notebook, not the number of notebooks. That's a really common mistake here. But either way, that doesn't really matter. All I know is, so here is, I guess first, like I was missing cost of a notebook, cost of a pen, and then if I change this color, let's change it to yellow. So two notebooks and three pens cost $16. So that's some clue about N and P. And then I also know that 4 and 1 cost 22. That's a second clue. So I have two equations, two missing things, and I solve. That's the process. So let's do one more, transfer into a function, because this is how we'll really often see these questions set up. Not so much the kind of more obvious math 10, like, oh, like random, like pens and notebooks, like where you're kind of cued to a system. So this one says a linear function has the form f of x equals mx plus b. It passes through these points 2, 5, and 5, 14. Find the equation of the function. Now, quick pause. We notice that the unknowns are not prices or numbers in this question. So our question is, what are the two unknowns? And then how does each point become a condition? So when I look at kind of what I'm given, I know points are x, y coordinates, right? X, y, x, y. So what I can kind of see is, well, those are my two conditions. Like those are my two pieces of information. How do I turn that 0.25 into an equation? Well, if I go f of x equals mx plus b, y is 5. So 5 equals m times 2 plus b. So that's actually an equation with m and b, right? If I write it a little more normally, I'd say 5 equals 2m plus b. So let's look at equation 2. Well, equation 2 says y is 14, so 14 equals m times 5 plus b, or 14 equals 5m plus b. So now if I look at that, I have two equations with two missing things, right? So I have two equations and they're both missing m, they're both missing b. Now I see I have a system to solve. And then again, this is just the rinse and repeat, the elimination substitution process. If you need help on that, go check out the skill videos where I'll get into that in a little more detail. This one I will do. I'll do substitution. It doesn't really matter. So equation 1, I have 5 equals 2m plus b. I can easily isolate b, so b is going to be 5 minus 2m. Pop over to equation 2. I know 14 equals 5m plus b, but I just said b is 5 minus 2m. So 14 equals 5m plus 5 minus 2m. So that's going to give me 14 equals 3m plus 5. Subtract the 5. 3m is 9. Divide by 3. M is 3. And I'm going to pop back over here. So 5 minus 2 times 3 is b. So b is -1. So I have my parameters now. B is -1, m is 3. And then I need to go back to the question, find the question wanted the equation. So the equation f of x equals mx plus b, f of x equals mx plus b. But we just said, well, m is 3 and b is -1. So the line is going to be f of x equals 3x minus 1. This is the way more common way you're going to see systems. Not to get too far into it, but like any function can give you some sort of information where you're kind of set up for these parameters, right? So for example, quadratic, it might be a couple points, or it might even be like, hey, you know this about the axis of symmetry and this about some other point, or like, you know, it hits a line at these 2 points. Like we have a lot of ways we can kind of hide this information in mathematics. But again, the big thing is if you don't know what's happening, you kind of think you're missing multiple things. Try to see if you have that information about each of those things. That's it. So again, kind of wrapping up, we can see this question maybe looks hard initially, but it is just that same structure, a different kind of surface appearance. So little checklist to wrap up. So when we have these hidden systems, things we're looking for is, can we name those unknowns? And then really importantly, number 2 is, can we find those 2 independent conditions, right? So it passes these 2 points or whatever those may be. From there, you just turn each of those conditions into an equation, and then you have 2 unknowns with 2 equations, and then substitution elimination. And you can check if the answer makes sense. Those wordy problems, it's going to kind of come to you. But yeah, feel free to verify if you need to. And that's it. Thanks for watching.